Hi, boys and girls. It's Miss Bissell. We are going to review today multiplying and dividing by a one-digit number. We are working on that fourth grade standard that we need to master in order to start multiplying and dividing by two-digit numbers, which is your fifth grade standard. So we're going to take a look at our first problem. You need to grab a piece of graph paper and a pencil and write this problem down. Pause me if you need to go grab your materials. If you're ready to roll, let's start with 6,058 divided by 7. So in order to be successful with this problem, first of all, we need to know the steps to multiplication in the standard algorithm, but we also need to know our 7 multiplication and division facts. So I am noticing that a lot of us are not proficient with our multiplication and division fact family, which means that we can figure them out with fingers and with some other techniques, but we've got to start working on practicing those. Multiplication and division flashcards are really good for that. Until you have mastered them, I would highly suggest that you either have your times tables out with you while you're working these kinds of problems, or if it's some kind of a test and you're not able to have those materials, you should be able to create them if you understand that multiplication is simply repeated addition and that your multiplication families are related to your division families. And we've been working on that in class as we do our spiral reviews, which are called the weekly reviews. So if I was not proficient with my 7 tables, I would certainly take a second and create the timetables out to the side. And the way that we do that, we just start with 7 times 1. We know any number multiplied by 1 is going to be itself because one group of 7 is 7. Then we move on. And what I like to do is I like to go ahead and just write 7 times 1 all the way down to 7 times 9. And then if you need help because you don't know them, then don't we just add 7 to each of our products to create this multiple list? So if you have to, you can use those finger calculators to do that. So once you've taken, it should take you no more than a minute to create your 7 facts. And then you are ready to roll, and you are not going to miss a problem because of carelessness, okay, if you know the steps. So let's review the steps real quick. We always start multiplying by the number on the bottom called the multiplier, and we start in the ones, we move to the tens, we move over to the hundreds, we move to the thousands, and our pattern is going to go moving from smaller place value to larger. We could even multiply a number into the millions by 7. But we're just going to stick with 4 digits for today. So we start with 7 times 8. 7 times 8 is 56. So 56 ones cannot fit in this one box, right? This is just like addition. So we're going to write down the 6 ones, but the 50, the front digit, we're going to rename it, all right, as 5 tens. So it's going to go above the tens place. Okay, now we're going to add it after we multiply. So 7 tens times 5 tens, 7 times 5 is 35, plus the 5 we're going to add gives us 40 tens. So the same concept here. We would put down the 0 tens, the 4, which is the 40 tens, gets renamed 400s. All right. Now we're going to move over to the hundreds place with our multiplication. 7 times 0 is 0, plus the 400s we added, we have a 4. And then we move over to the thousands. We didn't have to rename anything. So 7 times 6 is 42, and we can put that number out front. We place the comma between the thousands and the hundreds place. So what you've learned over the years is you would always have 3 digits behind a comma, your ones, your tens, your hundreds, before you move into your thousands. And that gives us a product, an answer called the product of 42,406. All right. It's always a good idea if you have a calculator to put it in your calculator and see if it's correct. So I'm going to put in 6,058 times 7. I get 42, 406. So I know my answer is correct, and I can move on. All right. Now let's review one-digit division. So we're dividing by a one-digit number. I intentionally chose 7 as the divisor because we've already created those facts. Now, when we divide, we're going to use the standard algorithm. The traditional setup that your parents, grandparents, and I learned was to set it up underneath, you call it a house, call it a shed, but your dividend goes here, your divisor goes outside of the house or shed, and the quotient, the answer, goes on top. So I'm going to take you through the standard algorithm with this traditional setup, and then the one that I really like that Ms. Holt showed you, which I really like because I'm seeing less careless mistakes on this one where we do the place value. So let's start with the traditional. So 7 does not divide into 6, all right? And this is really 6,000. We can't make any groups of 6 with 7. So we're going to divide into 60. So I like to put a little caret marker there so that whoever's looking at my work knows that I'm starting with 7 goes into 60. 7 goes into 60. Well, it won't go 9 times because 7, I would need 63 to make 9 groups of 7. So it's going to be 8. Now, if you use your times tables, what you're looking at is the multiple list. You're looking for a number in your multiple list that is 60. Since we don't have one, we are looking between these two. I would need 63 groups to make 9 groups of 7. I'm sorry, 63 to make 9 groups of 7. So I'm going to need to use this multiplication and division fact right here. 56 divided by 7 would be 8. Okay, I can make 8 groups of 7. If you know your times tables, you don't have to, go through all this. You can access what you need really quick just because you have already internalized those facts. Now, after we write our first digit on the quotient bar, we multiply. 8 times 7 is 56. And we're able to subtract. 4 is the difference. Now, if we would have put 9 on the quotient bar, when we multiplied 9 times 7, we would have gotten 63, and you can't subtract 63 from 60, so we would know that we would have to adjust our quotient down to 8. Now, once you have multiplied and then subtracted, we are ready to go into the next place value. So we're going to bring down the 5. And we're going to now divide 7 into 45. All right, so if you know your times tables, you know that 7 times 7 is 49, so that's going to be too big, right? We can't subtract 49, so we're going to use the 6. We can make 6 groups of 7 with 45 because 6 times 7 is 42. When we subtract, we get 3, and we're going to bring down the next digit, the 8. So we're really, other than the first digits, we're bringing down one digit at a time, multiplying, then we're subtracting and dividing again. So the steps are divide, multiply, subtract, bring down, and if you bring a number down, you have to go back and go through these steps again. If there's no more numbers to bring down, you're done. All right, so we just brought down the 8. So we just need to go back and start dividing again, right? So how many groups of 7 can we make with 38? And that would be 5. 5 times 7 is 35. 6 times 7 is 42. So that we wouldn't have enough, right? We would need to have 42 or more to make 6 groups. When we subtract, we get 3. There's no more numbers to bring down. The 3 is what we call the remainder. And then stop for a minute and think about what your answer means. It means that if you have 6,058 of something and you're making 7 equal groups, because division is dividing into equal groups, you're going to have 865 in each group of 7. And then there's going to be 3 left over that you're not going to be able to put in a group. Okay, so you got to understand what this means, okay, what your quotient means. means that we can make 865 groups of 7, and we would have 3 left over. That wouldn't be enough to make another group. All right, now let's look at that standard algorithm broken up into place values slots. So we, again, have the divisor 7, and this way you can do a comparison. I'm going to spread out this line pretty long because I like to leave one grid box between each digit in the dividend. Come down several rows and go right behind your digit and create your little place value box. All right, so same steps, except for I am going to attempt to divide into the first number. So I'm wondering how many groups of 7 can I make with 6? Well, any number that is less than your divisor, you can't make any groups because you don't have enough. So 0. 0 times 7 is 0. So that's 6 we're going to be using here. So what we just did was we are making 6 move over into the hundreds place, right? So we're renaming actually 6,000 as 60 hundreds. We didn't have any hundreds, so we have 60. Okay, so that is conceptually what we're doing. We did this here when we didn't multiply into the 6. I could have put a 0 up there and done one more step, but I just used the caret marker and went over to the 60. All right, now, how many groups of 6 or 7 can you make with 60? That would be 8 groups, and 8 times 7 is 56. So we have 4 hundreds that we couldn't make an equal group of 7 with. Okay, so those 4 hundreds are going to be renamed as 40 tens. We're putting it with the 5 tens we already have, so now we have 45 tens. That's what we did right here, except for bringing up the difference is not what we did. We brought down the next place value digit, but we're still dividing into 45. So how many groups of 7 can you make with 45? That would be 6. 6 times 7 is 42. When you subtract, you get 3. So this is 3 groups of 10 that we cannot make 7 equal groups with. So we're going to rename that as 31s, and we're going to add it to the 8 ones that we're getting ready to divide into. And that happened here, except for instead of bringing the 3 up, we brought the 8 ones down. All right. Now, 7 goes into 38. 5 times, we can make 7 groups of 5. We'd be using 35. So right here is our remainder. Our little 3 is our remainder. We get the same quotient, 865 remainder 3, okay? So this one I think helps you understand a little bit more what you're doing. The standard algorithm is where you are dividing into one place value slot at a time, starting with the highest place value. So we started by trying to divide into the thousands. That didn't work because we didn't have enough thousands to make one group of 7. So then we actually started with dividing into 60 hundreds. Okay, so it's really the same concept. All right, now to check division, we're not going to be able to put this in a calculator. If you put it into the calculator, 6,058 divided by 7, you get this number right here. All right, 865, and if you rounded it to the nearest hundredth, it would be 43 hundredths. We haven't talked about this concept yet. This is coming in the spring. So we can't use the calculator to check most of our division problems because we get these answers that we don't understand what they mean. So when we check division, we're actually going to use multiplication. And to check it, we take the whole number part of our quotient. So we would take our 865. We'll deal with the remainder in a minute. You multiply the whole number part of the quotient times the divisor. Okay, so 7 times 5 is 35. 7 times 6 is 42, plus 3 is 45. 7 times 8 is 56, plus 4 is 60. So I get 6,053. And then you need to add the remainder. So if I add the remainder, I get 6,058. What you're looking to see is this our dividend. And we started out with 6,058, or sorry, 6,058. It's the back number. You can see it better here. So yes, my answer is correct. You can always use a calculator for that. Take your whole number part of your quotient, multiply it times your divisor, add the remainder, and check to see if that was the dividend. If that was not the dividend, then we've done something wrong and we need to go back and find our mistake. Okay? So looking at dividing and multiplying by a one-digit number, looking at checking our work, because I'm seeing lots of careless errors on your work, whether it's graded multiplication and division in isolation or mostly on your weekly reviews, which, that's 10 points off your spiral review just for a careless error. It's not that you don't know how to do the concept, it's that you're not taking the time to check your work. Okay? So I'm going to give you a couple problems to practice, and you're just going to do your best and check your work. All right. Have a great day.